In this video, we're going to continue our discussion about the law of sines. We are going to do 4 examples, but in this situation, the pictures are not drawn, so that is the added difficulty to this. I will not be drawing these pictures to scale. We are just looking to solve each triangle by finding the missing sides and missing angles. Now, since this is the law of sines section, we should become familiar with the 3 different classifications that the law of sines works for. That's the side between the 2 angles, or when the side is not between the 2 angles. Now there is a third relationship, the 2 sides and the angle, when the angle is not between the 2 sides, but this is a dangerous one. This is called the ambiguous case, because without the picture being drawn, it could be one of 3 answers, no solution, 2 solutions, or 1 solution, and you'll see that in the 3rd law of sines video in my video series. So what we're going to do today is look at these 2 examples, the angle side angle or the angle angle side, which is a lot easier to do. If you haven't seen part 1 of my video, which had the pictures, I strongly recommend you look at it, because we're going to be using shortcuts learned in that video to work on and quickly do these problems in this video. So here's what we know. We know our 2 angles in this side. Now, I again am not going to draw this to scale. I'm just going to do what I call draw the Dorito. I just draw a normal triangle. I don't care about the angle measurements at all. And I just start labeling clockwise the angles in capital letters, just like the book or the worksheets do. I know my angle A is 50 degrees. This is one thing I don't have to check. My angle C is 20 degrees. So what I'm trying to find is all the other missing pieces and parts, but I do know that the side A is 3. Now, if you were confused as to how I knew side A was here at the bottom, it's because I kind of modify a little bit of the hinge theorem, and the hinge theorem basically states, and I'm really simplifying it here, that the big angles across from the big side and the small angles across from the smallest side and the medium angles across from the medium side. Basically, the angle created by the 2 segments, its width is going to create the side across from it, like the hinge of a door. The hinge of a door widens and closes based on the angle that you open it. So this opening creates the 3. So this is side A to angle A. Therefore, this would be side C to angle C, and this missing piece here, this missing angle B, would create missing side B. You can see I'm using lowercase letters for sides and uppercase letters for angles. So I know my sine of 50 degrees, all right? And this is the law of sines, which states that the angle across from its side is proportional or equal to, actually more than proportional, it is literally the ratio is equal to the sine of the known angle to its missing side. And if I solve this cross multiplication problem, I will get to the answer for side C. Now we have to find the next one, so we need to find angle B and side B, but angle B wasn't given. But what's nice about this is I can take my original setup and take the 2 angles I was given, the 50 degrees and the 20 degrees, and find the missing angle by subtracting from 180. 180 minus 50 minus 20 is 110 degrees. So this 110 degree angle is across from the missing side B. So when we get done with this problem, we will know what the missing angle is, and we will also find the missing sides C and B. This problem that gave us this A, C, and A gave us, and I'll highlight this here, this gave us this A, this C, and this A. So this triangle at the very beginning was angle, angle, side. So this is an angle, angle, side triangle. Now let's use our technology to find the missing answers. Okay, so taking our calculator, and it is in degree mode, but that's not going to be important since we're actually not going to be finding any missing angles, only missing sides. We're going to then do our crisscross multiplication. 3 times sine of 20 divided by sine of 50. And this should give us our smallest side, side C, which is at 1.34 hundredths, or 1 34 hundredths. So I hit second enter, and I go back up this to, instead of 20, we're going to type the 1 over the 2, second delete to insert another 1, so we're at 110 degrees divided by sine of 50, which gives us 3.68. So these are our missing pieces. Our missing pieces, since we easily figured out that the angle B was 110 degrees, our side C across from the 20 degree angle, that was 1 34 hundredths. And side B across from the 110 degree angle was our largest side at 3.68. So that is solving for the triangle. Let us move on to the next problem here. So we're going to draw our Dorito again. We draw the Dorito giving me angle A, which is 70 degrees. Angle B, which is 60 degrees. Angle C is unknown, but we do know side length C, which is 4. Side length C4 is across from angle C. So this is going to be missing side A. This is going to be missing side B. So what we're trying to find in this problem is angle C, side A, and side B. So from the very start, since I don't want to get too far before I address this, this is an angle side angle picture. It's an angle side angle picture, so now we can just type in things that we know to get us the missing, so finding angle C is definitely the most important thing here, and we have to find the difference between 180 and these two given angles, and if we go 180 to minus 70 minus 60, this is equal to 50 degrees. So now we have all three angle measurements here, and we have our first of three problems answered. We will take this relationship between the 50 degrees and the 4, and that will set up our our key law of sines equation. So sine of 50 over 4, this is equal to, let's solve for A next, sine of 70 over letter A, and then we can have sine of I'll not change my formatting on you, sine of 50 divided by 4 to find my missing piece here. This is going to be the sine of 60 divided by B. We have also done that one as well. Okay, so let the calculator do the work for us. So going up here, we're going to move this over here, and now I'm going to have 4 times the sine of 70 divided by the sine of 50. And again, if you haven't seen the previous video where I show all my work to get to a shortcut like this, I strongly recommend it, because this may seem a little weird that this is working. This gives us 4.91, or 4 91 hundredths. Now if I hit second enter, I'm going to go 4 times the sine of 60 divided by the sine of 50, which is 4 52 hundredths. So now I have my two answers to the two problems, and I'm definitely going to check out the hinge theorem to make sure that it fits. So letter A is going to be 4.91, and letter B is going to be 4.52. So was 4.91 across from the biggest angle? The answer is yes, it was. So the hinge theorem seems to be checking out. Was the smallest side across from the smallest angle? Yes. And you don't need to check the middle sized one by logic. You've already kind of done that by finding the biggest and the smallest. If you only have 3 choices, the third one's going to be in the middle. So there's our second of 4 examples. We're now going to go to our third example here. And our third example is going to be another Dorito here. You may want to pause the video and see if you can work on ahead of me. Well, our letter A is unknown. We do not know angle A. We do know angle B. We do know angle C. We do know side B, so where does the 2 go? Does it go to the upper right, upper left, or bottom? It goes to the upper left, because if this is angle B here in the corner, across from it would be side B, which in this case is 2. So this is going to set up our key. Sine of 10 divided by 2. Now, this means we can find side C, which is right here, and we can do that by knowing our sine of 100 divided by C. We have to figure out angle A, and knowing that these two add up to 110 degrees, then angle A has to be 70 degrees. And that 70 degrees is then going to go to side A. So the sine of 10 from our key is going to be equal to the sine of 70 divided by A. So it's time to get the graphing calculator out, and it's time to do the problem. 2 times sine of 100 divided by sine of 10. That answers 11 and 34/100ths. That is for side C, which is going to be our biggest side length because it's across from our biggest angle. If I hit second enter, this gives me a little change here because I'm going to delete that 1 and change that 0 to a 7, and now I got exactly what I want. And this gives me 10 and 82/100ths. So let's actually plop this into the form. Let's just plop this into our answers just so things kind of look normal here. So here we are. Our C is equal to 11.34. That's what it's equal to. Our A is equal to 10.82. And it really does look like we have small, medium across from the medium angle, and large. And again, another way to check your answer is to just go sine of 10 divided by 2 gives you this decimal, which is equal to the sine of 70 divided by 10.82. Now again, we've rounded 10.82, so this isn't the exact answer, but it is close to it. So you can see that the 0.868 is matching there, and the rest didn't because we used an approximation of our side length. And then finally, we're going to go side 100 divided by 11 and 34/100ths. Oops, there we go. And you can see the 8.868 is fine. Great. So where do we go from here? Well, where we go is to this last problem, which has a neat twist in it. So if I draw the Dorito, you're going to see what happens at the very end of the problem, which is going to bring up something kind of cool in this situation. So in this problem right here, I'm going to have my angle A, which I don't know. Don't know my angle A. Nope, nope, nope. Let me move that down just a little bit. Okay, so I don't know my angle A. Do I know my angle B? Yes, I do. I do know my angle B is 20. Oops, yeah, there we go. And then angle C is 70. Okay, great. And I know my side A, which happens to be 1. Okay, cool, because I know that this is across from here. So what am I going to do first? Well, I'm going to obviously find this missing angle, and if I find the missing angle, it's 90 degrees. Holy smokes, this is a 90 degree, this is a right triangle. So it is possible to do this problem by other means than SOHCAHTOA and by the Pythagorean theorem. In fact, what's cool about this is we can take the sine of 90 divided by 1, and we can find the other two missing sides. We can find side C and side B. So let's go with side B first. The sine of 20 divided by B, and here's the sine of 90 divided by 1 is equal to the sine of 70 divided by C. Okay, couple cool things, right? So I'm going to turn on my calculator here here we go, calculator. And I am in degree mode, so if I type in the sine of 90, you will see that that is equal to 1, which is pretty wild, right? So what happens is that I'm going to go 1 times the sine of 20 divided by 1. So essentially this problem is just 1 times sine of 20, or in this case just sine of 20. Wow, that turned out to be a pretty easy problem. There's your sine of 20. And now that is going to be 0.34 or 34 hundredths. And now I'm going to go to sine times 70, because this is 1 times sine of 70 times divided by 1, or literally 1 times that divided by 1, which is that, or sine of 70, which is 0.94. So, geez, that was kind of wild, because this problem shows you that you actually can use the law of sines on right triangles. You don't have to use Pythagorean theorem or SOHCAHTOA trigonometric properties. It's kind of cool. Unfortunately, this video does not derive this for you, but it is kind of a cool illustration to show you that the big and the small fits and the medium fits. It's just kind of a cool situation that if you have a right triangle, you can use the law of sines. If you don't have a right triangle, you have to use the law of sines or the law of cosines based on what's given you. In the next video, you're going to do the law of sines with the ambiguous case, because you'll note that the last two examples I gave you here, this was an angle side from the very start, and this was an angle side angle. So what's going to happen is you're going to get the side angle situation, and you're going to learn about this ambiguous case, and it's a doozy, and you're definitely going to be having this on assessments. So study up and get ready for that third video.